So the agenda today, I'll first give a quick overview of who is doing the spying. Then I'll give some historical context about what they've been doing and how we all got here to where we are today. Followed by how the spying is being done, and then try and convince you why you should care. And I'll finish off with how this can be mimicked with a few Python tools. So let's set the stage about who all is involved. So we have the Five Eyes, which is the US, the UK, Canada, Australia, and New Zealand. While there are multiple agencies within each country that are involved in the data sharing, the predominant ones are the National Security Agency in the US, the Government Communications Headquarters in the UK, the Australian Signals Directorate, Canada's Communications Security Establishment, and New Zealand's Security Intelligence Service and Government Communications Security Bureau, I think it is. We then have Nine Eyes, which includes France, Denmark, the Netherlands, and Norway. Germany felt a bit excluded, so we now have the 14 Eyes as well, including Germany, Belgium, Italy, Spain, and Sweden. Then we have the 41 Eyes, which is 14 Eyes, plus those that participated in the US coalition in Afghanistan starting in 2001. So visualizing this can make it seem that it's a bit difficult to maintain one's privacy. So you might be wondering how exactly they are doing that. So basically, they're drinking directly from the hose. So the Tier 1 network, the backbone of the internet, allows vast amounts of data to pass via the simplest path. Tier 1 companies include Level 3, AT&T, Verizon, Deutsche Telekom, and about 15 others. And some even own their own transatlantic and trans-Pacific cables. So major companies like Facebook, Microsoft, Google tap directly into these Tier 1 via edges, or they too own their own under-the-sea cables. And so the NSA covertly does the same thing. They tap the edges shared with Tier 1 companies. Also, probably by brute force, I couldn't help but use an XKCD comic here. There is that program called Muscular that taps into Google and Yahoo directly. So I think some is also done by force. And so now you might be thinking, why does this matter? And why should I care? So first off, there's a lot of unanswered questions. The first one that I have is, how do these companies not notice being backdoored? Either their security sucks, or they're lying when they're denying cooperation. And then how is foreignness determined? Am I being roped in because I interact daily with non-US citizens? Or maybe because I'm here in New Zealand? Are you now a target because you're one hop away from me? What is done with data accidentally collected on Americans? There have been articles of the NSA spying on ex-lovers and tracking people's porn habits. And finally, how secure is this information? Whether I'm foreign or not, if these agencies are able to crack encryption, I'm sure that there are black hats able to do the same, or perhaps more likely, I don't know if their database admin has actually changed the default password. So maybe you're thinking, so what? I've got nothing to hide. I am not a criminal. Well, then I'll ask you, do you have curtains or blinds in your windows? Maybe you'll let me see your credit card bills or your text messages. Maybe you lead a boring life and are willing to share all of that. But if you got nothing to hide, then that quite literally means that you're willing for me to photograph you in the nude. And I get all that rights of those photographs, and I can show them to your neighbors. So maybe you're thinking, it's not like the NSA really cares about all that. Well, there are some examples of metadata that they do pay attention to. This particular slide is taken from the EFF presentation from 30C3 in 2013. So they know that you rang a phone sex service at 2:24 a.m. and spoke for 18 minutes, but they don't know what you talked about. They know that you called a suicide prevention hotline from the Golden Gate Bridge, but the topic of the call remains secret. Then they know that you spoke with an HIV testing service, then your doctor, then your health insurance company within the same hour, but they don't know what was discussed. So it's kind of obvious what they do collect can tell a significant story. And whether or not that you're okay with allowing unknown watchers into your life is certainly your call. But just because I have stuff to hide does not make me a criminal, nor should I be a target of surveillance. There's even like 10-year-old Facebook posts that I would cringe at reading now. All right, so enough with all the seriousness. Let's figure out how we can do this ourselves. This is a Python conference after all. All right, so the media tells me that I need to look like this, you know. I feel like Mr. Robot or something right now. All right, so I think this makes me ready to at least pretend I'm a black hat, right? Yeah, right?
You can still see your face.
I got my sunglasses somewhere, right? All right, so let's do this. I'm ready. So I use a couple different Python libraries here. The main one being called Escapee, which is just a TCP dump or Wireshark in Python. The overall idea is just the wiretapping part with particular filters. So if you actually want to like store the data, then you probably have to just collect it all that you physically could, connect to a database and store it somewhere, and just do queries off it. So the following is just a proof of concept of how actually collecting particular information is quite easy. So again, proof of concept presented without warranty. I'm not condoning the use of traffic spying or sniffing, but if I were you, I would probably go to a cafe with open Wi-Fi networks. So a quick introduction to Escapee. This makes me cringe, but this is what they suggest from Import Star. So here's, so I'm sniffing for TCP traffic, basically HTTP traffic, and only getting 10 packets. So if we take a look at what that is, you can see I have 10 TCP packets and nothing else. And the result of that, I had to snip it. You can see a bunch of information here. If we just grab the first packet, we can use the show method, and it gets pretty printed, essentially. We can see the Ethernet layer, the IP layer, and the TCP layer. And literally, that is all that we need to know, and just essentially playing around with different filters. So the first snippet, because I wanted super slick code names too, I've called this snippet tempura, like tempura, but the food. So this particular snippet is inspired by the xkeyscore program. So basically, show me everyone that has searched for a particular term. So I have offline a PCAP file, and then loading it. Or if you were to do it actively, basically TCP and that host. And I've limited it to 300 packets, or you can save it for later. So if you take a look at the packets, I do indeed have 300 TCP packets. If we look at the summary of them all, here's it dumped out. If I just take a look at one of them, I can see that there's the raw payload there. If I just get the layer, and then you know how when you search for something, there's like a Q equals kind of thing, or P equals. So I just parsed this out of the raw payload, and I was, at the time, searching for Montreal. The second packet, maybe about 70 packets later, my second query was sniffed. I was looking for best chocolate in Montreal. And then the third packet, the best coffee in Montreal. You can see where my priorities lie. So I should make note that this was before Yahoo sent all of its search traffic over HTTPS. Only switched over a few years ago. So it would be definitely a lot more difficult if this was over HTTPS. So snippet 2. I've dubbed this omnivore, like carnivore, but omnivore. It's an xkeyscore query, maybe something like show me everyone from a certain country that has visited a certain extremist forum. And for this, I did not dare visit an extremist forum. I'm probably already on a list already, but I didn't want to make it worse. But this is the general approach. So I have this filter of like TCP and some host. I have some data offline already, and I have 258 TCP packets. If I take the 8th one, I guess, you can see I have some payload information there. And I get that and print it. I was visiting PyLadies because I'm a good person. And so basically, it's as simple as like if the extremist term that I'm looking for is in the raw payload of the data. Thank God it's false. So then I did like a quick and dirty like traceroute function. This wraps around Escapee's traceroute method. And then, let's see, I was tracerouting Spotify and get a bunch of IP addresses. I take those IP addresses and get the coordinates for each IP. So I have a few. And then I'm creating like a GeoJSON file or blob that is essentially JSON with some like coordinate information on top of it. So I have this information, and then you can actually copy and paste this into GitHub's gist functionality, and they'll automatically render it. So you can see, I was actually in Canada when I was tracerouting Spotify.com, located in Sweden, and you can see that the hops actually went through, I think, Netherlands and Colorado. So even though the beginning and end was two non-US countries, the fact that it goes through the US is still under US jurisdiction, which is a lot of, happens for a lot of internet traffic to begin with. All right, so snippet 3. I've named this Teflon, because that's what echelon sounds like to me. So we're trying to answer the query of give me all the emails with a certain term in the body of the email. So I'm sniffing for SMTP traffic. I have it offlined already, and I have a bunch of packets, as you can see. I'm taking packet, the 12th packet, and just printing the raw payload. And that kind of looks encoded to me. So decode it, and it's an email address. Take the following packet, do the same thing, some encoded string, and it's actually a password prompt. The next one, I take it, and I wonder what happens when I decode it. And some password. This is just sample data. This is not actually someone's like email and login, or email and password login. So here, this is just a quick and dirty like filter packet by a particular string. So I'm wanting to see if someone mentioned attachment in the email. So I found a query, and it shows me that, yes, indeed, someone was talking about, I had to snip it, unfortunately, but someone was talking about attachment in this email. All right, snippet 4, we got 2 more. I've called this cold brew, because since reading about storm brew, it gave me the craving for cold brew coffee. And here, we're wanting to see chats for a given user during a certain time frame. Here I'm sniffing for IRC traffic, the standard port of 6667. And we get like a bunch of packets, even some DNS queries are in there. Some pretty printing functionality. You can see that there's some sort of chatting going on. And here's the same filter packet by string function that I had. So now I'm searching for a particular user, Amarak. And you can see a bunch of like conversations from Amarak. The final one, I called this Lucky Charms after Shamrock, because that's what I craved after reading about Shamrock. And with this snippet, we're trying to mimic the Hacienda program by finding all exploitable machines in a certain country. So this IP address, it's actually for the host for the former New York City Mayor Rudy Giuliani. In January, the then President-elect Trump had named Rudy Giuliani to be his cybersecurity advisor, which I found hilarious. So the former mayor had this like InfoSec consultancy like company, and the site actually no longer exists. But I was able to port scan that site before it was taken offline, and you'll see why I think it's hilarious in a second. So we scan it using mmap, Python mmap library. And I didn't include the whole thing here, but we get back a list of exposed ports and services, including OpenSSH version released 10 years ago, an anonymous LDAP, and an exposed MySQL database. We also could see that, that the site that was running was a 5-year-old version of Joomla with unpatched vulnerabilities. So yeah, with this kind of information, you could easily figure out what you want to exploit. It's not like all that information is out there to begin with. So if we want to take a look at what this IP address points to, getting some coordinates again and creating a GeoJSON, and putting that on GitHub, we can see that Rudy Giuliani's host was in Denver. OK, so hopefully I've sufficiently scared you. Perhaps you're architecting your own new bunker with some tinfoil hats, canned goods, and maybe some signal scramblers. Or maybe I've inspired you to become a script kiddie yourself. Just don't blame me if you're caught. The purpose of this talk was to both talk about what's going on in the world, as well as convey how easy it is to pick up this stuff, even if you're not an aspiring black hat. As I mentioned in the beginning, this talk is not to teach you how to protect yourself, because in all honesty, and I hate to say this, there isn't a corner in which you can hide. There are certainly provisions one can take, but as I say in the security industry, the defensive side will always be on the losing end of this fight, as there are always adversaries finding new ways to exploit things. We very well might enjoy all what technology has brought us. For instance, we're able to work from home without pants, or stalk ex-lovers with Facebook and Instagram and whatnot. You can even hack together your own script kiddie stuff like me. But it's essentially up to us to keep this conversation going. Being complacent and ignorant, we can't just blame technology, because we essentially are the ones that give technology its purpose. So again, unfortunately, I have no advice on how to protect yourself, just to be more vocal. And so with that, I will close this with a pretty apt quote from Martin Niemöller. First, they came for the socialists, and I did not speak out because I was not a socialist. Then they came for the trade unionists, and I did not speak out because I was not a trade unionist. Then they came for the Jews, and I did not speak out because I was not a Jew. And then they came for me. There was no one left to speak for me. Thank you.